In our previous lectures, we discussed the expanded program on immunization and the target diseases it aims to prevent. Now, let us explore the vaccines themselves, their types, composition, storage requirements, and handling protocols. As community health nurses, we are directly responsible for ensuring that vaccines are stored, transported, and administered correctly to preserve their potency and continue protecting lives. Vaccines come in different types depending on how they stimulate the body's immune system. Live, attenuated, and inactivated vaccines is one category. Live vaccines like BCG, measles, and OPV contain weakened forms of pathogens that trigger immunity without causing the disease. In contrast, inactivated vaccines such as IPV contain killed organisms or causative agents, offering safety but sometimes requiring booster dosages. Toxoids and recombinant vaccines. Toxoids like diphtheria and tetanus contain inactivated bacterial toxins that train the body to neutralize harmful effects. Recombinant or subunit vaccines like hepatitis B vaccine use parts of the pathogen, like surface antigens, to elicit immunity safely. And then we have the combination vaccines, such as the pentavalent vaccine, combines multiple antigens in a single shot, simplifying schedules, improving compliance, and reducing the number of injections for children. The Bacillus calmette-guerin or BCG is a live attenuated vaccine given intradermally at birth, usually on the right upper arm. It is extremely light and heat sensitive, so it must be stored between 2 to 8 degrees Celsius and used immediately after reconstitution. The vaccine protects against severe forms of tuberculosis, especially TB meningitis and miliary TB, which are most dangerous in infants. Nurses must ensure proper technique. Too shallow and the vaccine won't be effective. Too deep and an abscess may form. The oral polio vaccine or OPV is a live vaccine that is highly heat sensitive, while the IPV or inactivated polio vaccine is injectable and more stable at 2 to 8 degrees Celsius. Maintaining a strict cold chain is critical, especially for OPV, which loses potency quickly if exposed to heat. These two vaccines work together. The OPV promotes intestinal immunity and urge protection, while IPV provides individual protection against paralysis. This dual strategy ensures comprehensive immunity across the population. The diphtheria pertussis tetanus or DPT vaccine combines three components: D for diphtheria toxoid, P for pertussis, either killed, whole cell, or acellular, and T for tetanus toxoid. It is stored at 2 to 8 degrees Celsius and must never be frozen, as freezing denatures the toxoid proteins. The vaccine is administered intramuscularly at 6, 10, and 14 weeks, forming the primary series for infants. The nurse should check expiration dates, shake the vial gently before use, and ensure correct injection sites to minimize local reaction. The measles or MR vaccine is a live attenuated vaccine that must be reconstituted only with a supplied diluent to maintain its stability. It is highly sensitive to heat and light and must be stored at 2 to 8 degrees Celsius. And any reconstituted vial must be discarded after the immunization session, and it cannot be reused. The vaccine is given subcutaneously or intramuscularly at 9 months, following the national MR schedule. Maintaining high coverage is key to preventing measles outbreaks and protecting communities through herd immunity. The hepatitis B vaccine is a recombinant subunit vaccine made from the hepatitis B surface antigen or HBsAg. It is given intramuscularly and in the anterolateral thigh for infants, starting within the birth dose within 24 hours after delivery, followed by additional doses for durable immunity. The vaccine must be stored at 2 to 8 degrees Celsius and never frozen because freezing damages the antigen and renders it ineffective. By providing the birth dose on time, nurses help prevent perinatal transmission and future cases of chronic liver disease and liver cancer. The Hib vaccine protects against severe infections such as pneumonia and meningitis. It uses conjugate polysaccharide technology, which helps infants' immune systems respond effectively. The vaccine in the pentavalent form is stored at 2 to 8 degrees Celsius, administered intramuscularly, and must not be frozen. It is integrated in the pentavalent formulation, which is a practical innovation that increases compliance, reduces missed dose, and enhances overall coverage. The pneumococcal conjugate vaccine, or PCV, protects against Streptococcus pneumoniae infections that cause pneumonia, meningitis, and sepsis. These are major causes of under 5 mortality. It is a conjugate vaccine targeting multiple serotypes and is administered intramuscularly. Like most vaccines, it is stored at 2 to 8 degrees Celsius and must never be frozen. Beyond preventing illness, PCV also reduces antimicrobial resistance, since fewer infections mean less antibiotic use, and this is a crucial public health gain. The rotavirus vaccine is a live oral vaccine that prevents severe diarrhea and dehydration, which is a major cause of infant hospitalization in the Philippines. It is heat sensitive and stored at 2 to 8 degrees Celsius away from direct light. Dosing is age restricted, meaning it must be given within specific age windows. Otherwise, it's no longer valid. Nurses should counsel parents on its oral administration and ensure that doses are completed to build full immunity. Proper storage is crucial to maintain vaccine potency. Most EPI vaccines require temperatures between 2 to 8 degrees Celsius, but OPV needs stricter cold handling due to its high heat sensitivity. Toxoid and recombinant vaccines like DPT and hepatitis B lose potency if frozen. So freezing must be avoided at all times. Monitoring tools such as the VVMs or vaccine vial monitors and temperature logs must be checked and recorded at every session to ensure safe administration. Remember, improper storage can waste vaccines and compromise immunity. During vaccine transport, maintaining temperature stability is just as important. Ice packs must be properly preconditioned to prevent direct contact between frozen packs and vaccine vials. Packing protocols require tight lids, foam pads, and protection from sunlight to prevent temperature fluctuations. Inventory management follows the first expiry, first out, or the FEFO principle, ensuring vaccines nearing expirations are used first. These details may sound small, but they ensure that every dose administered remains safe and effective. To close, here are three essential principles. Use WHO pre-qualified carriers and cold boxes for outreach activities to ensure global standards of quality and insulation. Document temperature readings at both dispatch and arrival points and act immediately if cold chain breaches occur. Follow the vial return policy, which allows the return of unopened and potent vials per the multi-dose vial policy for reuse within the recommended time limits. Follow these procedures to uphold accountability and ensure every vaccine delivered protects and not harms the patient. In summary, maintaining vaccine quality requires both scientific knowledge and discipline in practice. Nurses are at the heart of immunization safety, from storing and transporting vaccines to educating families and ensuring every child receives full protection. A potent vaccine in the right hands means a protected community. Always remember, vaccine safety begins with you.